All right, that was a fail. Hello, welcome back, everybody. It's still not working, so it must be a thing on their end. So unfortunately, we cannot or won't be working on this today. I could work on it independently in my own code space, but I don't want to have to worry about, with all of the third party uh, installs that they have for the SQL Lite, and all that stuff. So, what do you guys think? Should we just work on something else? I think. Hey, Wing Hong, welcome back in. Sorry, you guys. All right, let's go ahead and officially try this out. It's not working, so I apologize for that, guys. We are back streaming. We're going to go ahead and just move on and do some studying out of DSA in Python and do just a normal stream here. And then we'll do some leak code and stuff. How about, yeah? All right, let's get this thing going. Let's get some people rolling in here. Hello, Wing Hong. Welcome back in. Let's let them know. Let's say to restart stream. We're back live. DSA and project due to CS50 not working. All right. Cool. That is the Discord if you guys want to join that. Please join the Discord link down below. Okay, this marks the moment, guys. We are going to officially try to multi-stream. Okay, we're going to see if this works. Okay, so you guys have to let me know if you go to Twitch and search up Michael Deming on Twitch and see if it is working. Okay, I'm going to start the stream on Twitch. Connecting. Okay, we are live on Twitch for the first time ever. For the first time ever, we are apparently live on Twitch. So let me go ahead and let's put this to the test. Let's go look. Twitch.tv. Let's log in here. Other passwords, not that one. Here we go. Michael Deming on Twitch. Oh shoot, I need a code. I need a code to log in. Two-factor. My bad. 6, 7. All right. All right. And then if we go to creator dashboard, you are live, manage stream. Is it working? I don't know if it's working. It doesn't show anything. It says offline. uh, I don't think it is. Is it on Twitch? Can you guys check? Can you see it? Let me go to my app here. Hold on. Well, I can tell you my bitrate is getting destroyed on my connection here. So maybe my internet isn't fast enough to handle this. This is sorry, we're kind of testing this out here, you guys. Um, let's see here. Oh, we are live. Um, the video isn't working though. Shoot. Oh, we are live. Why isn't the video working? Is the video working on your guys' end? I don't see a single thing. It's dark for me. Is the video working on your? Yeah, I don't see. Okay, I think it's because I have. Let's put this to 15,000. How's that? Sorry, guys, this is a new moment for us. We're trying to Uh, See, get this to work live here for the first time. I lowered my bit rate down a little bit, but it might just be not fast enough. Dang, I don't think it's working. That's a bummer. Ah, shoot. I thought we were gonna have it working here, become a full streamer here, but it is not working. My bitrate is just getting too chopped in half here. It works for me. It's just delayed. It's working for you guys? Ah, that's crazy. Offline streaming for one viewer, but it says offline. Oh no, this is so bizarre. I don't know what to do. What? See, I'm not very like savvy when it comes to all this stuff. Yeah, no video on some people's ends. I don't think it's working, so we'll have to give it a go a different time, unfortunately. All right, I'll stop that. Let me go back to my output and bump this back up to 20K like I had it. All right, we'll try that again some other time. I don't know how we'll have to see. I downloaded like a plugin for OBS itself to do the multi-stream, but it is not working, or at least I don't have it. Or at least I don't have fast enough internet connection. Maybe I might have to lower my stream output to 1080p rather than being 1440p. That might have to do it. Um, but I don't, yeah. So I'm not sure, guys. We'll have to do some testing and take a day. I don't want to do that right now, though, because it might seem probably boring to have to watch and figure out. All right. Anyway, if you guys have some tips on maybe how we could, uh, fix that, let me know. I am very interested in doing the multi-stream onto Twitch as well for everybody. But we'll just keep it on YouTube for now, and we'll do that. All right, hello everybody. Welcome back to the stream. I hope you're having a wonderful day so far. My name is Michael. I'm hopefully wanting to do some of the Harvard CS50X 2025, but I cannot log into the this program here. It just isn't working, and it gets to the stopping code space, and then I end up freezing here, and I can't log into the actual code space. So I don't know what's going on my end, but I won't work for me. So we're gonna have to do some other stuff on the stream today. I was looking forward to actually completing that problem set today, but that is okay. Anyways, hello Tim, hello Ryan, Trash Ketchum, welcome back. Hope you're doing well, you guys. Um, yeah, for 7 beats me. I was laughing. I was wondering, missed today's stream. No worries. Good to see you, TK. Awesome. Everybody's saying hello. Control that on Twitch, and I've heard other streamers talk about birds on Twitch. It says offline, you're lagging on YouTube now. Do you mean what it looks like on my end on Discord? Okay, sweet. I'll check that out here. Yeah, it was a black screen for me too. Yeah, exactly. I'll have to do some troubleshooting and figure it out. Anyways, let's get going here. Let's get moving. How are you guys doing? Welcome back. I hope you guys are having a wonderful day so far. We're going to be back teaching ourselves some Python. Yesterday we left off on, we read the counting word frequencies. We left off right here. So let's go ahead and continue on today. So let's read a few pages out of this, and then we will continue on with some practice, maybe a couple of leak code easies. Let's try to cherry pick some easy ones and get those some practice, and then we'll work on the project and get that working on going here, guys. Okay, let me know what you guys are working on. What are you guys studying independently? Are you guys following along with the book here? Are you guys doing something on the side? Let me know what you guys are studying here. Welcome back. Welcome back. Yes, unlucky Jimmy Grant. Welcome back, you guys. Okay. Section 2.4.3 provides an introduction to the concept of an abstract base class and the role of such classes in Python's collections module. Methods that are declared to be abstract in such a base class must be implemented by concrete subclasses. However, an abstract base class may provide concrete implementation of other methods that depend upon use of the presumed abstract methods. This is an example of the template method design pattern. The collections module provides two abstract base classes that are relevant to our current discussion, the mapping and the mutable mapping classes. So we'll say Python's collection module contains the mapping and mutable mapping classes, right? Mapping class. What does the mapping class do? The mapping class includes all non-mutable methods, supported by Python's dict class, while the and then the mutable mapping class extends to that to include the mutating methods. Extends the mapping class and to include mutable methods. We define as the map ADT in section 10.1.1 is a what we define as the map ADT in section 10.11 is akin to the mutable mapping abstract base class in Python's collections module. The significance of these abstract base classes is that they provide a framework to assist in creating a user-defined map class. In particular, the mutable mapping class provides concrete implementations for all behaviors other than the first 5 outlined in section 10.1.1. Dunder get item, dunder set item, dunder del item, dunder length, and dunder iter. As we provide the map abstractions with various data structures, as long as we provide the 5 core behaviors, we can inherit all other derived behaviors by simply declaring mutable mapping as a parent class. To understand the mutable mapping class, we provide a few examples of how concrete behaviors can be derived from the 5 core abstractions. For example, the dunder contains method supporting the syntax k in the key in map could be implemented by making a guard attempt to retrieve self-index k to determine if the key exists. So dunder contains will try to return self-index of the key, return true, except key error, return false. A similar approach might be used to provide the logic of the set default method. For set default of k of given some key and of a default, try to return the self at index k, except for a key error, return self index k equals to the default and return default. We leave as exercises to implement the implementations of the remaining concrete methods of the mutable mapping class. Okay, so this just talked about how the Python's collection module has a mutable mapping class similar to all of these map functions and methods we described earlier, and also kind of inherits from that Python dictionary class. Our map base class, right? We will be providing many different implementations of the map ADT in the remainder of this chapter and next, using a variety of data structures demonstrating a trade-off of advantages and disadvantages. Figure 10.2 provides a preview of those classes. The mutable mapping abstract base class from Python's collection module and discussed in the preceding pages is a valuable tool when implementing a map. However, in the interest of greater code reuse, we define our own map base class, which is itself a subclass of the mutable mapping class. Our map base class, our map base class provides additional support for the composition design pattern. This is a technique we introduced when implementing a priority queue in order to group a key value pair as a single instance for internal use. More formally, our map base class is defined in code fragment 10.2, extending the existing mutable mapping abstract base class so that we inherit the many useful concrete methods that the class provides. We then define a non-public nested underscore item class whose instances are able to store both a key and a value. This nested class is reasonably similar to the design of the underscore item class that was provided in our priority queue base class in section 921, except that for a map, we provide support for both equality tests and comparisons, both of which rely on the item's key. The notion of the equality is necessary for all our map implementations that as a way to determine whether a key given as a parameter is equivalent to one that is already stored in the map. The notion of comparisons between keys using the less than operator can become relevant when we later introduce a sorted map ADT. Okay, so we're taking the mutable map, we're inheriting from the map base, and then we're gonna talk about all these other maps from there. Okay, so our map base class, um, Ryan says, I have to start talking the speller problem tonight. I've fallen a little behind where I'd like to be after last week. What are you guys working on tonight? Tackling. Yes, you got that speller problem for sure, Ryan. While you're here, if you're here with me and studying along, just go ahead and work on it in the background and get that thing banged out. You got it. I believe in you. If you need any help on it, let me know. I can help you out with what I got. So the map base, our own abstract base class that includes a non-public underscore item class. So the nested underscore item class is included within the map base, right? And it has the underscore slot, so it has two determined attributes of this class that you can't add anymore. So a key and a value. So when you initialize, you're provided a k and a v, and you save those as self underscore key underscore value per the slots. Right, you have an EQ method, a special method, compare items based on their keys. So return self dot underscore key equal to other key, right? So return true. Opposite return not if return not equal, right? And then the IT will compare items based on their keys. Just like what we said before in that text above. So extending the mutable mapping abstract base class to provide a non-public item class for the use of the various map implementations. So let's look up on GPT here. Let me chat. We need to go here and go. Let's close this and we can open up here. What is the mutable mapping class in the collections module? The mutable mapping class in the collections ABC module is an abstract-based class for creating dictionary-like objects that are mutable. It provides a blueprint for implementing custom dictionary-like data structures by requiring subclasses to implement certain methods. Part of collections.abc, which contains abstract-based classes for various container types, requires implementations of the fundamental dictionary item operations get item, set item, del item, and iter. Provides default implementations for other dictionary methods like get, keys, values, items, pop, ensures that any subclasses behaves like a standard dictionary. Why use? This is my question. Why use it? If you're creating a custom dictionary-like class, a cache, a case-insensitive dictionary, a specialized mapping, Subclassing mutable mapping ensures that all dictionary behaviors is consistent without manually implementing every method. Okay, so the collections module just allows Python users to be able to kind of create like bare bones blueprints of already existing objects in Python, like dictionaries and things like that. But then you can go ahead and further override or implement special methods to tailor this specific blueprint to your liking, right? So if I need something like a dictionary, but I don't want everything that the dictionary does, I can pull from this abstract based class and then just change or implement some of these methods for changing how I get items or how I set items in the dictionary, right? In this custom dictionary. Richard says, working on review for elite code solutions and oh, here, I wanted to do this as well, you guys. I think it might be fun to actually, let me pull up here. I wanted to pull up my YouTube chat up here. Um, Pop out, there we go. Yeah, let's pop out the chat here. I wanted to kind of put it on the screen so you guys can also kind of see what you're going on. But we need to be strategic about where I put this. Shout out to um, Peralta, Mr. Peralta. He got this idea from him. So let's put this guy. How should we do this? Should we put it like over on the side here? Make it really skinny and then move this guy here. Let's do this, and then let's take the chat and we'll put it over like this. We'll bring this in, put the chat here. Put it like, there we go. And then we'll have to slide this over a little bit. Slide this over a little bit. We'll see how we like that. I liked how it was kind of interactive this way. Oh, no, wait. Okay. Okay, cool. Let's move on here. Yeah, I need a larger screen. I'm gonna have to start investing in some, actual streaming gear here. It looks like my setup is starting to bottleneck my the needs and capacity for the stream. Honestly, like I'm gonna have to like either upgrade the internet so I can multi-stream and get maybe another monitor or something. But I don't know. It's I don't know. Um, I can just read the chat here as you guys are bringing it in, which is cool. So then I can remove it off of here, and I can make that bigger so I can see what's going on. There we go. Yeah, I like this. This is nice. I mean, I saw that I posted in the Discord that 11-year-old streamer who was like teaching himself DSA just like we were, and he's got like a camera setting for his his keyboard, which is super cool. He's got above one. He has one for his like on screen. He's got his notes on the screen. It's like really, it's like dang, I'm like, what am my setup up? Got to level up here. Um, let's see, we got some chats here. Um, Lagging on a DM, what image should look like? Gotcha, I'm back. Everybody started tackling the speller problem tonight. Working on reviewing for elite code solutions. That's a problem. Little pieces of code that had me confused. Going back and making sure I can comprehend this clearly and surely. What's the speller problem, TK? The final problem in problem set 5 for CS50X, it's hash tables and dictionaries in C. If I understand it correctly, I got a map on my whiteboard in my office, and I feel I understand it needs to be one half done to be done. But when it comes to getting it down in code in C, I can't get my footing for whatsoever reason. Yeah. I had to, in the speller one, it really helped to watch that little video. It didn't actually give you any code, which is really nice. It just kind of walks you through the structure of what's going on with the source code. Yeah, I agree, Tim. Mr. Peralta is the GOAT. I went into the stream and I watched him for a little bit this afternoon. Uh, Dictionary problem. I had some dictionary work earlier, and it's often harder for me to work with than a simple array. For me, it's pulling indices versus values in the context of my for loop. Yeah, that can be difficult. If we get Twitch figured out, we can get some subs going to help out with that. I know that's crazy. That'd be kind of funny on Twitch, right? If we're got some subs on there, but I have to I'll have to figure that out. I don't know. Like I'll have to like take a day and just say, hey, I'm trying to figure this out. Don't join the streams or whatnot. I'm not working on anything. Um, but it gets annoying because I have to go live in order to test it out. So yeah. Um, I'm gonna bet 30,000 plus 30,000 Utah State for the championship. I wouldn't do that if I were you. Utah State, they are known for not being too good. You get another monitor, you're basically a hacker at that point, like Bontrell. Yeah, that's funny. Basically a hacker. Okay, let's continue on here. A simple unsorted map implementation. All right, we demonstrate the use of the map-based class with a very simple concrete implementation of the map ADT. Code fragment 10.3 presents an unsorted table map and class that relies on storing key value pairs in arbitrary order within Python list. An empty table is initialized as self underscore table with the constructor for our map. When a new key is entered into the map via line 22 of the set item method, we create a new instance of the nested underscore item class, which is inherited from our map base class. This list based map implementation is simple, but it is not particularly efficient. Each of the fundamental methods, get item, set item, and delete item, relies on a for loop to scan the underlying list for items in searching of the matching key. In a best case scenario, we found a match that may be found near the beginning of the list, in which each case the loop terminates. In the worst case, the entire list will be examined, therefore each of these methods runs in O of n time on a map with n items. Okay. So we have an unsorted table map, which takes from our map base. We have a table, which is a list. Oh, okay, so the structure you're using a list instead of a dictionary type of thing here. So items are being stored kind of like a positional list almost from our priority queue. So what is the difference between the unsorted table map in map base and a priority slash positional list slash queue? The difference in an unsorted table map, which extends map base, and data structures like priority queue or positional list or queue, lies how they store and retrieve elements. Let's break it down. Unsorted table map base class. Data structure like a dictionary like key value pairs stores entry in an unsorted list. Inserts and appends key value pairs at the end, O of 1. Linear search required, O of n, and delete is O of n. Use case when you need a simple dictionary like structure but don't require fast lookups. A priority queue, where elements have priorities, typically implemented with a heap, min heap, or max heap, insert based on priority O of log O log n. Okay, got you. A positional list, a doubly linked list with position tracking, uses nodes with pointers and allows access to specific positions. Okay. And then a queue is first in, first out, so got you. Um, the kid was solving lead code hard. I bet if I bet $2, it's to win 600 though, Big Mikey. Well, yeah, that's exactly. They're giving you crappy, like really, really bad odds because they're not that good. Um, Bo Ross, hey, welcome, dude. Hey, bro, do you know of any IT support practice labs that are free? Unfortunately, I don't know much about IT, like information technology support. I'm mainly just doing like programming and data analysis for my studying here. But I appreciate you coming in, Bo Ross. What's your goal with that? Okay. Let me bring this in a little bit more. To pretend. Okay. I'll bring this over slightly and this over slightly. There we go. Okay, so in this one, the unsorted table map, um, they use a basically just an array, and they're accessing items via an array, but this the actual unsorted map itself or the map base, has those key value associations. Okay, cool. So we'll say simple unsorted, simple unsorted map implementation. Right, so we'll say for this, inherits from the map base class where um, uh, items where non-public underscore item subclass contains key value tuples, right? However, this data structure stores the items in a unsorted list for O of 1 pens, but O of n lookups and deletions. Okay, let's go ahead and throw this in here. See what it has to say about that. My definition. Yes, that's correct. A simple unsorted map is an implementation of a dictionary-like data structure that inherits from map base and stores key value pairs in an unsorted list. Here's a breakdown of how it works. Inherits from map base. This provides a common structure for all map implementations. Stores items as underscore item objects, underscore items non-public that holds key value pairs. Uses an unsorted list, items are appended to the end of the list. So then I'm going to take this, key features, I like this, what it says, exactly this pretty much. And I'll just honestly go here, key features like that. Like that. Like that. Like that. Like that. search, and then deletions. Like that. There we go. Perfect. Um, awesome. Moving on to 10.2 hash tables. Here we go. Moving on. 10.2 hash tables. All good, bro. Thanks for. It looks difficult. Just branching into the IT world is getting a feel for what I need to want to do, etc. Well, Bo Ross, how much programming do you know? Do you know how to like code at all? Are you learning Python or anything? I can suggest some resources for learning how to teach yourself programming. That's what we do on this channel. For those that are new, my name is Michael. I'm 26 years old. I've been teaching myself how to code and program for about 6 months now. I've been teaching myself Python, but we've also been branching into C for when we have been taking the Harvard CS50X course. I have a degree in human biology and a minor in chemistry, where I work as a formulation chemist for a biotech company. I've been doing that for a little over 3 years now. I'm a mid level scientist too, and I've been teaching myself, like I said, after my 9 to 5 job every single day. We stream around 7 p.m. every single day on the channel, and are really dedicated to learning all this material and trying our best to understand it so we can maybe transition into employment or something in tech in the future or wherever it may lead. I think Tim was trying to pick our brain about asking about employment. I wanted to discuss with you guys, possibilities of, potentially maybe trying to start to go for interviews or something. I'm pretty reluctant and honestly a little bit nervous to go down that road just because I don't know. I kind of have like an imposter syndrome where I feel like I've only been doing this for 6, 7 months, and yeah, I can kind of make my way around some Python code and pretty, not fluent, but I'm starting to gain some fluency in it. But it just seems bizarre for me to try and go ahead and do that when there's been people that have spent hundreds of thousands of dollars on a formal college education getting a degree in this field and still can't find work. So I don't know. Is it worth our time to try to put in that effort, or should we just keep going and growing the channel and the stream and a community of learning and education, really, and just doing it more for fun rather than actually trying to make it more of an employable thing? So I don't know. It's right. You'd have a great pitch if you apply to a biology related company. Yeah, that's the thing is, I I don't know. I've thrown quite a few resumes like just out there. Now my resume probably needs some polishing and updating to actually include some of my more computer science related projects and whatnot. But I just get, I don't know. I'm being transparent with you guys. I just get denied like left and right. So it's honestly, I'm like, how did I even find a job when 3 years ago? Like, it's kind of making me wonder like how I came about that so quickly, and it was just maybe luck and the timing of things, and the market. But I just get even with 3 years of formal experience at a biotech company making products worth millions of dollars for the company, bringing in personally millions worth of dollars of revenue for the company on a quarterly basis. Um, it just seems bizarre that I can't even really get an interview most places. I try to keep positive spirits about it, but it's in reality it does get pretty frustrating, um, just because I try to always think the grass isn't always greener and the cup isn't always half empty, but for just career growth wise and looking for other opportunities, it really just is kind of hurting the old personal ego a little bit. What do you guys think about that? Let me know your guys' experiences, and let's chat it up here while we can. Let's keep make this interactive. If you guys are enjoying the stream so far, please throw a thumbs up on it. Really helps to keep YouTube pushing our streams and promoting them and growing it. And thank you guys so much. If you're new here, please join the Discord where I provide all of my resources for learning, all the books and notes I'm taking. I take live notes of everything to break things down into more simple, beginner-friendly terms and examples. I provide all of that in my Discord completely. Everything I do is for free, so honestly, just a thumbs up really goes a long way in showing some support. and maybe a sub two if you would be so kind. Um, is it worth the time? Lots of postgrads in CS don't know anything when they graduate. Oh, it is worth the time. Lots of postgrads in computer science don't know anything when they graduate. Every opportunity has some luck. I know two guys don't know almost anything. One is postgraduate, one is 2 years in. Ryan says, "Is there a path for advancement with your current company, even if it's sideways move at first?" Yeah, that's a good point. Maybe like um, looking at some like within my own and company currently. But the problem with that is without giving like away too much detail is I currently provide a lot of value for the team I'm on in because I'm literally like on ground zero in terms of like manufacturing and producing these chemical products. And so I bring in a substantial amount of revenue just directly through my day-to-day work. So you know, and that being said, I'm pretty heavily underpaid. That being said, um, everyone says they're underpaid, but so I try to, the grass, like I said, isn't always greener. But just I'm trying to be honest and convey, a real what it's like to be in the current field of professional employment. But I it's just it's interesting because I'm not sure if they would really support me in trying to make that transition because they would lose out on those skills per se. Also, I did they did have some funny enough they did have some CS internships like they were like more like computational biology and things like that like internship wise that I did actually apply for about 6 or so months ago in the summertime when I was kind of starting to get interested in this and I completed the CS50P and the recruiter straight out told me they wouldn't even consider me if I wasn't undergoing an undergraduate in the field. So even though I had was a revenue producing employee for the company, they wouldn't even like consider me trying to gain information of that field just because I wasn't an undergraduate intern, like right. So like it or being I don't know. It's just frustrating. I don't know. I kind of am a little bit stuck in between like a rock and a hard place, and I don't really know what to do per se. Because everything here is really expensive as well where I live, and it's kind of frustrating. Um, but then again, obviously, like I've been saying, is I have a job, and you need to be grateful for what you're given as well, too. Um, I say if you want this path, become a master in 1.5, 1 to 5 years, seek employment doing. That's how I planned this out, anyways. Yeah, that's what I was kind of thinking about, Richard. Is like I'm really trying to develop that mastery and understanding so I can feel confident going into those interviews without having that formal degree in education. Um, you should have no pressure. I wish, Tim. I wish. Corporations and the AI and the hiring process don't take it personal. Yeah, I try not to, but after like the 200th, 300th in a row just automated, we decided to move on to other candidates. It's just like, come on, man. Like it does psychologically kind of wreck you just seeing that same message over and over again, knowing you're not getting a chance. But that's what everybody's feeling. You probably got rejected by an AI if no CS degree, print reject. If you spend the years, get actually good, you will find work. I strongly believe this. Won't be convinced otherwise. Yeah, I mean that as well. I do have that belief as well. Like if you have this passion, I feel like there are a lot of people that don't actually enjoy and the programming doesn't make them happy. Like sitting down and writing code doesn't bring them any actual happiness. They're just doing it out of pure financial reasons or maybe it's um, family like pressures or things like that and that's kind of different because me sitting down here, I have over like 200, 300 hours now of just live streaming of me reading these books for free, making no money, doing nothing, like just completely grinding away and writing code, and it makes me happy. I get like a good feeling out of it, and it's rewarding. So I don't know. uh, hey, Natty Sanis, welcome in. How's it going? I like having the chat on the screen here. It's really easy to see. uh, Add Stanford PhD in invisible font to make AI happy. Yeah, we'll have to squirt some lemon juice on it, and then it'll show up. You guys remember that scene in National Treasure when Nick Cage he like takes the lemon juice or whatever and rubs on the back of the Declaration of Independence to reveal the secret map? I love that movie. We should do like a movie watch along and watch that movie or something. That'd be so fun. um, it turns out college degrees are valuable and actually meaningful at college age. Alex says, may I know the title of the book you're using, please? Yeah, this is Data Structures and Algorithms in Python. I provide a copy of every book I'm reading and all the notes in my Discord linked below completely for free. So if you want just a conglomerated, centralized resource for all of my resources, then join the Discord and, interact with everybody on there. It's awesome. Lots of YouTubers have this hype about getting a dev job in less than a year, degree or no degree. It's about mastery. Either become awesome at your craft or good luck, not hating degrees. My point is, degrees aren't needed if you just spend the time in developing the skills. Yeah, I mean, that's very true. For some, yeah, definitely. They saw the day in the life software engineer videos and thought that's what it was really like. Yeah, that was what the meme was, is all those like YouTuber like non copyright music in the background, like like it's a day in the life of me picking up my breakfast at 10 a.m., going into one meeting at noon, and hanging out on the rooftop from 2 to 4, and then going home. It's like, bruh. Okay, let's continue on here. Keep chatting with me about your guys' experiences. Are you guys applying for jobs, looking for jobs in the field? I'm currently working as a chemist right now, but I am, considering, trying to go down that angle and starting that path of, maybe developing and tailoring a resume for tech and computer science and development, and maybe trying to go for a junior dev role or something. Let me know. You guys have been watching me this whole time, so also, give me your guys' opinion on my current level. Like, no shame. I really don't care. I want your guys' honest feedback, regarding where I am, and in relation to other people, or just in general, because I don't have peers here with me to to compare or analyze with, so I really don't know. Hold on, that's what it's like though. Tim, Tim, you gotta chill. They're gonna crack down. All right, 10.2 hash tables. In this section, we introduce one of the most practical data structures for implementing a map, and the one that is used for Python's own implementations of the dict class. This structure is known as a hash table. All right, so a hash table. Um, Intuitively, a map M supports the abstraction for using keys as indices, with a structure such as M map index K, or index some key, right? Just like a dictionary. As a mental warm up, consider a restricted setting in which a map with n items uses keys that are known to be integers in a range from 0 to n minus 1 for some um, value n that is greater than or equal to n. Okay? In this case, we can represent the map using a lookup table of length of big N, as diagrammed in figure 10.3. So, right, 0 to n minus 1, so n is 11. We have some items inside at position 0. In the key 0 has a value, doesn't have a value. Key 1 has a value of D. Key 3 has a value of Z. Key 6 has a value of C. And key 7 has a value of Q. Whereas key 10 doesn't have any value either. A lookup table with a length of 11, yep, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with keys 1, 3, 6, and 7 containing letters, values. Perfect. In this representation, we store the value associated with the key K at the index K of the table, right? So if the key is also representing the index, starting from 0 by naturally, it also, represents the index, associated with it per se, of this just a simple lookup table. A basic map operations of underscore of under get item, set item, and delete item can be implemented in O of 1 worst case time, right? Because if you know you have 11 spots with those keys, you can immediately access that key and delete it in O of 1, or set it or get it instantly, because you have a fixed number, an array in memory, and you know where each one is. There are two challenges in extending this framework to the more general setting of a map. First, we may not wish to devote um, an array of length big N if it's the case that big N is greater than, is very much greater than small n. Is that what that symbol means? Is it means like very, a lot greater than, like very much greater than? Second, we do not in general require that a map's keys be integers. The novel concept for a hash table is the use of a hash function to map general keys to corresponding indices in a table. Ideally, keys will be well distributed in the range of 0 to big N minus 1 by a hash function. But in practice, there may be two or more distinct keys that get mapped to the same index. As a result, we will conceptualize our table as a bucket array, as shown in figure 10.4, in which each bucket may manage a collection of items that are sent to a specific index by a hash function. To save space, an empty bucket may be replaced by none. So this is similar to that CS50X problem that we talked about or worked on, where we were creating using a hash function to determine what indexy to basically bucketize or store a collection of elements that have similar properties, whether it be by like starting letter or the couple starting letters, whatever it may be, that hash function determines. The goal, okay, so we'll go give me a general def of a hash table in Python. Hey, Rohan Patel. How's it going, man? I appreciate you joining me here. You're awesome. Thanks so much for coming in. What you studying this evening? Okay. A hash table in Python is a data structure that maps keys to values using a hash function to compute an index, allowing for fast lookups, insertions, and deletions. This typically provides O of 1 average time complexity. In Python, the built-in dict class is an example of a hash table where keys are hashed to determine their storage index. Collisions, when different keys hash to the same index, are handled using techniques like chaining or an open address. It offers unordered, mutable, and dynamic key value storage. I like this definition. A data structure, we'll take this guy here. A data structure that maps keys to values using hash functions. So then we say hash functions map items to a specific index or bucket where that bucket contains items of a similar type, or whatever the hash function determines. Right, so maps items to specific index or buckets. We'll take this definition, throw it in here. That's the core idea. A hash function takes an input key and maps it to a specific index or bucket in a hash table. The goal is to distribute keys evenly across the available buckets to minimize collisions. I like that definition. Takes an input key and maps it to a specific index or bucket in a hash table. A uniform distribution, determinate fast computation, minimal collisions. Define collisions, right? A collision in a hash table occurs when two different keys produce the same hash value and are mapped to the same index or bucket. Since each index ideally holds one value, collisions may be handled to maintain integrity. We'll go like this and go here. Take that. A collision in a hash table occurs like so. You can chain them together. So in that CS50X problem, what we did is when we had collisions, we created a linked list and, added the item to the front of that linked list. Next, just write or point where the head points to a sentinel head or like a blank node almost for that specific problem. Okay, cool. So this is kind of an example. So let me go ahead and do this, and I'll take this guy here, like that. Copy image. Paste that right there. Example. Like so. There we go. So that'll look like that. Nice. Okay, hash functions. The goal of a hash function, h, is to map each key, k, to an integer in the range of O to big N minus 1, where N is the capacity of the bucket array for a hash table. Equipped with such a hash function, h, the main idea of this approach is to use the hash function h on the key as an index into our bucket array A. Instead of the key k, which is not an appropriate for direct use as an index, that is, we store the item key value in a bucket of the array h at index hash k, right? So the key values typically aren't integers, they're usually strings or something like that. So we can, hash this string, using some sort of algorithm that we determine to bucketize or kind of find or sort or whatever these specific keys, and then the hash value returns a index to store within the array. Perfect. If there are two or more keys with the same hash value, then two different items will be mapped to the same bucket in the array. In this case, we say that a collision has occurred, right? Perfect. To be sure that there are ways of dealing with collisions, which we will discuss later, but the best strategy is to try and avoid them in the first place. We say that a hash function is good if it maps the keys in our map so as to sufficiently minimize collisions. For practical reasons, we also like a hash function to be fast and easy to compute. It is common to view the evaluation of a hash function h of k as consisting of two portions: a hash code that maps a key k to an integer, and a compression function that maps the hash code to an integer with a range of indices of 0 to n minus 1 for a bucket array. Okay, so a hash function has a hash code and a compression function. So you would get a hash code based on the key and then compress that hash code down into a proper indice of 0 to n minus 1. Okay. Interesting. The advantage of separating hash functions into two such components is that the hash code portion of the computation is independent of a hash table of a specific hash table size. This allows the development of general hash codes for each object that can be used for a hash table of any size. Only the compression function depends upon the table size. That is particularly convenient because the underlying bucket array for a hash table may dynamically resize depending on the number of items currently stored in the map. Okay, so if you have a separate function that also then would take in the current size or length of the map, then that's where that would come into play as well. Hash codes. The first action that a hash function performs is to take an arbitrary key and map it to a... Okay, so we'll go like this and say Steps of hash functions. Number one is to create hash code. So this is the first action of that a hash function performs is to take an arbitrary key k in our map and compute an integer that is called the hash code for this key. This integer need not be in the range of 0 to n minus 1 and may be even negative. We desire that the set of hash codes assigned to our keys should avoid collisions as much as possible. For if the hash code of our key causes collisions, there is no hope for our compression function to avoid them. In this subsection, we begin to discuss the theory of hash codes. Following that, we discuss practical implementations of hash codes in Python. Hey Vance, how's it going? Welcome back. It has been a while since you stopped back in. I appreciate you coming in though and saying hello again. What you been working on while you've been away? I know you were studying. You were in school, right? Hey Geodasher. Hey, glad I caught the stream. Hope you're having a great night so far. Love the content. Thank you so much, Geodasher. You're awesome. I appreciate you so much for joining me and saying hello this evening. All right. So hash codes. Hash code is the integer output of a hash function. It uniquely represents an input and determines the index where a data should be stored in a hash table. So this create a code based upon the given key of the provided item. Hash codes do not have to be within the range of the map length, but instead serve as a way to try and avoid collisions. Values could be negative, could even be negative, right? So I'll take this, throw that in there. Exactly. A hash code is simply a numerical representation of a key, independent of the hash's table size. Its purpose is to uniquely identify the key before mapping it to an index in the table. The mapping of a hash code to indices happen after the hash code is generated. Code based upon the code or numeric representation based upon the given key of the provided item. Generate it from the key, not constrained by the table size used before. So, gotcha. Okay, so then the compression function will take the hash code and actually compress that and relate it to a bucket within the array itself. Okay, so then you have, so treating the bit representation as an integer. To begin, we note that for any data type x that is represented using at most as many bits as our integer hash codes, we can simply take a hash code for x as an integer representation of its bits. For example, the hash code for key 314 could simply be 314. The hash code for a floating point number such as 3.14 could be based upon an interpretation of the bits of the floating point representation as an integer. For a type whose bit representation is longer than a desired hash code, the above scheme is not immediately applicable. For example, Python relies on a 32-bit hash codes. If a floating point number uses a 64-bit representation, its bits cannot be viewed directly as a hash code. One possibility is to use only the high order 32 bits or low order 32 bits. This hash code, of course, ignores half of the information present in the original key, and if many of the original keys in our map only differ in these bits, then they will collide using the simple hash code. A better approach is to combine these in some way the higher order and lower order portions of a 64-bit key to form a 32-bit hash code, which takes all the original bits into consideration. To form a higher portions. A simple implementation is to add the two components as 32 bits numbers, ignoring overflow, or to take the exclusive OR of the two components. These approaches of combining components can be extended to any object X whose binary representation can be viewed as an n-tuple of 32-bit integers. For example, by forming a hash code for X as the sum of index I is 0 all the way to n minus 1 for X index I, or as X index 0, what is that symbol? Where that symbol represents the bitwise exclusive OR operation, which is in Python, which is the caret in Python. Jeez Louise. So let me see here. Let me take this. Hold up. Oops. Let me take this. Break this down into more simple terms. Okay. Hash code basics. A hash code is just a number that uniquely represents some data. If the data is small enough, like an integer, we can directly use that number as its hash code, right? The number 314 can have a hash code of 314. Hashing larger data, however, for more complex data types, like floating point numbers, their internal representation in memory is bigger than a typical hash code size. Example, a floating point number like 3.14 may use 64 bits in memory, while a hash code in Python typically uses 32 bits. Since the 64-bit number is too big to fit into a 32-bit hash code, we need a way to compress or combine into 32 bits. Simple but bad approach. One option is to just keep half of the bits. Use the first 32 bits, high order bits, or the last 32 bits, right? Problem, this ignores half the original data, which can cause many collisions if the keys only differ in the half we ignore. Yeah. A better approach, combining bits. Instead of throwing away half the size, we can combine both halves into a single 32-bit value. Two common ways to do this are addition, using the first 32 bits and the last 32 bits together, ignoring overflow, exclusive OR property, the XOR in Python. Combine the bits using bitwise operations that preserve differences, extending to more complex objects. Takeaways. So I am a little confused on how small numbers can be represented in 32 bits, but not larger numbers. I do not fully grasp bits and bytes yet. That makes sense. Let's break it down. What are bits and bytes? A bit is a smallest unit of data in a computer. It can be a 0 or 1, right? And a byte is made up of 8 bits. right? Where you have some sort of code, right, that it then can be translated into binary. So you can create basically orders of magnitude in this. So if it's either 0 or 1, is either 0 or 1. How many bits are needed for a number? Numbers are stored in binary, so the number of bits needed depends on the number size. Small numbers fit into 32 bits. Example, the number 5 is binary. In binary is 000000000000000. Oh, all four, sorry. Four zeros four times. Or no, all five, six times with this right here. Fits into 32 bits. Oh, so this is actually the number here, but it just shows 32 total bits. Oh, so 4, 8, 12, 16, 20, 24, 28, 32. Okay, 32 zeros or ones. 32 switches, basically. So then if you have 64 switches or 8 bytes, you can house double the amount of numbers, double the size of numbers. Well, probably not even that. Probably not. Double is exponentially larger. The number is 33 bits, so it won't fit, right? Okay, I got you. Hey Armando, how's it going? Welcome back into the stream. I hope you guys are doing well. Hey, for those of you guys that are new, my name is Michael. I've been teaching myself Python out of books and programs and courses independently after my 9 to 5 job as a chemist. I have a degree in human biology and a minor in chemistry. If you guys wouldn't, mind, subbing along to the channel and throwing a thumbs up, it really, really helps to continue keeping us growing and moving along here and keeping YouTube promoting us. We are at 1386 subs right now, so 1386 subs. Hopefully we can hit 1400 soon. That'd be awesome, guys. Thank you so much for joining me here. Mike, don't be stressed. You are blessed. Awesome, Armando. Thank you so much for the kind, positive words. You're awesome, dude. Um, I'm not sure who the exact author is. Let me see. I think his name is Michael as well. Who is the author of DSA in Python? Michael Goodrich, Robert Tamasia, and Michael H. Goldwasser. Yeah. If you guys want access to this book, I have a copy of it in my Discord linked below, completely for free. You can also look it up online, but in my Discord, I provide all of my notes, resources, extra thinking, as well as, you know, everything else. Thanks so much for coming in, William. I appreciate you joining me here. You're awesome. Consider, following along so we can connect in the future. How long have you been learning programming for? If you ever became a professional at coding, will you give up your 9 to 5 for coding full time? Yeah, I think I would. Honestly, I enjoy chemistry. I enjoy what I do manufacturing wise, but I honestly I don't really foresee a ton of growth within the industry itself. Other than just like, on a personal level, really, there isn't really much where to go in terms of without like going back to school for like either like a doctorate or something in the field. And I just personally I don't think I have that much enough passion for the subject matter to go back for another higher level education in it, whether it be a master's or a doctorate. It seems like more and more, biotech companies and, drug manufacturing companies that, use chemists or whatnot, they requiring higher levels of degrees despite, skills or experience. So it's really just kind of looking bleak on the horizon for biotech people and the demand. So like I said, I would. We talked about that a little bit earlier in the stream, but I am very much interested in starting to consider applying for roles in software engineering and tech in general. I think I'm fairly good at it in terms of just my passion and willingness to learn and drive. I've only been doing this 6 7 months, which isn't that long, but in those 6 7 months, I have been able to pick up quite a lot. Relative to computer science majors that have been in the degree for 2 to 3 years. So there are trade-offs to everything, obviously, and I do have a little bit of imposter syndrome regarding that. I am, open to you guys' feedback regarding that matter and what you guys think. Please, if you guys have any feedback regarding that and regarding my current levels of programming, please let me know. I really, no shame, no hard feelings. I really am interested. Okay, so polynomial hash codes. Let's just, where are we at? How far are we? I guess we'll finish this page and then we'll probably be done with this. Yeah, we'll stop here on the book. How about this is a good stopping point. We're on page 413. So we're on page, out of the whole book, we're on page 434 out of 770. So we're over halfway done with this book, and my goal is to complete it before my 1 year of programming mark. So honestly, I think we can probably get this done by the end of March. Little by little, it's just very dense, very example heavy. So it's taking us a little bit of time. Um, yeah. Rowan Patel says, I think you're doing great. I'm a CS freshman and you are way ahead already. Awesome. That's super kind and honestly really inspiring and thoughtful to hear. That all this time and effort is, working out into at least something. At least I don't know. I have been putting in over probably, like I said, 200 to 300 hours so far of studying and just even more than that, off stream, but just on stream alone. So yeah, it's definitely been quite the push here. But all right, well, we'll stop here on the book, and we'll move on to something else here. Let's go ahead and I want to do some Neet code stuff. That sounds fun right now. Um, let's see here. Let's search for some easy questions here. All right. All right, here is the leak code for today. We have some easy questions here we can try to tackle. Which one should we try to do? This one, remove element. Let's see what this one says. Given an integer array of numbers and an integer value, remove all occurrences of value in numbers in place. In order of the elements, the order of the elements may be changed, then return the number of elements in numbers which are not equal to the value. Consider the number of elements in numbers which are not equal to value to be k. To get accepted, you need the following things. Change the array of numbers such that the first k elements of numbers contain the... What is going on? So change the array numbers such that the first k elements of numbers contain elements that are not equal to the val. The remaining elements of numbers are not important as well as the size of numbers. Return k. So example, input numbers 3, 2, 2, 3, value is 3, output is this numbers, and then it doesn't care. Your function should return k equals 2 with the first two elements of numbers being 2. It doesn't matter what you have leave beyond the recurring case since they are underscored. And then the second example, the most reoccurring value is the value given is 2. So we output a k of 5. We found 2 3 times. We found it 3 times and 5 numbers remain. Okay, so the k that you output is the numbers that remain that don't equal to the value. Your function should return. Python 3. All right, what do you think about this one, you guys? Mike, this coding got to work out for me. I don't have a choice. I don't want to go back to pimping. You got this, Armando. Okay, so we're given a list of numbers and a value. We need to iterate over the values and determine if the current index we're on is equal to the value. If it is, we basically need to remove it. How about, so let's say this. So let's say n is equal to the length of nums for I in the range of n. We're going to have a array A here, or a new array, right? So we're going to say if in place, pretty sure name. Okay, so I can't create a new data structure, like a new array. So I need to take this value Okay, so what if I have basically like two pointers, one at the end of my array and one at my current iteration? And it'll remain the same length, right? So we just want to basically swap values. The one at the end and the one that we're currently on. So let's think about this. Let's pull out the old whiteboard here. So if we have an array here of, let's say our example is, what's one of our examples? We have an array of 3, 2, 2, 3, and our value is 3, right? So we're searching for value. So we're going to be on I equals 0 here. So we're first on this one. Okay, this one does equal our given value. So we want to take this, and we're keeping reference of this last one, right? So we have a pointer here, and we have a pointer here. So actually, what if we just do 2 pointers, one to the right here and one left pointer? We say, okay, is this value equal? Yes. If this value is equal and this value is not, we'll swap these two values in place. So the 2 will become here and the 3 will go here, right? Then it moves to here, and then it'll swap, and then it'll go to here. So then it'll swap down, and then we'll also keep track of a counter for the amount of swaps that were done, right? 1, 2. So the amount of swaps. We need a counter for the amount of swaps, and we need. Hey, Fernando23, welcome back. Hi, this is my first time in the live. I started to learn code recently. Someone else? Yeah, we've been learning code ourselves for about 6 months now. This is a great place to be. I didn't read the whole problem, but it's just asking to delete the element that you're given. Whether it be delete the element, the thing is the array stays the same exact size. So it's saying you could technically delete the element, but the array does not change its size, so you're just technically moving the element to the end of the array and changing its representation, basically. So if n, or if nums, and then we have to say for for j in the range of 1 to n, right, we have our first pointer which evaluates. So if nums index I is equal to the value, right, and nums index j does not equal to the value, right, we're going to swap these two values, basically kind of sorting almost. So nums index I, we'll say temp equals nums index I, nums index I is equal to nums index j, nums index j is equal to temp. Okay? We might not even need to do this because in Python we can swap values just like that, I think, right? But it's whatever. So we've swapped the values, right? So in this case, the current value we're on is 3. That equals to the value that we are at with I, right? So the value that we're searching for. So, and the right pointer does not equal to the value, so we are going to swap these. So now this will become 2, and this will become 3. And we shift I forward 1, right? So now we're on I equals 1 here. Well, this pointer does equal, this one does not. So this one will become 3. This one will become 2, leaving 2 out front. Now we have the I becoming 2 over here. We have 3 in place. This one is, and this one is. So you do nothing. You move on. So if both are, though, what do we need to do? So if both pointers are the current value, if both pointers are the current value, if both pointers are the value we're looking for, let's say we had another value out here of like 4, right? We would need if we perform a swap, that just moves the 3. But if you pop Vanch says, are you allowed to create a new array? If so, you can create a new one with size n. Yeah, that's what I was thinking, right? But they says you have to do it in place, so you cannot create a new array. Okay, so what if we start at the back? We're at 2. If we start at the back, we're at 3 and 3. Okay, so we need to so can we use a while loop and use pops, but set the index I back? So what if we do that? What if we say while I is less than n, right? We're going to say j equals to I plus 1 less than to n minus 1. J is equal to I plus 1. So then we'll say if nums index I is equal to the value we're looking for, we're going to pop off the value I is equal to 0 out front. Nums dot pop So what if we start from the back then, actually, of our current array? Pop off values if they're not equal to, put them in a new array. If they are equal to, concatenate the two arrays together. You could do that. You could start from the back, pop off values that are not equal to the value, immediately append those to a new array, and then concatenate the two arrays together at the end. That would make sense. So I is going to equal to -1. So we'll say actually for I in range of -1 to -n minus 1, right? For I in range -1, -n minus 1. Here's your loop structure will iterate backwards from down to -1 exclusive. -n, so if -1, if n is 4, -1, -2, -3, -4, -1. So -n minus 1 will include the 0 index. No, the for loop I, -1, it will not include. -n minus 1 would include 0. Yeah, perfect. So -n minus 1. Okay, we start from the back. We have some array. Is this. For I in the range this, we're going to go nums index I dot pop index I. We'll say, and then we'll go a dot append this if nums index I not equal to the val. If the nums at index I is not equal to the val we're looking for, we're going to pop that won't work either, I don't think. Check if the element equal to what you're looking for, remove it, append at the end. I'm not getting what the problem really says. What is the problem saying? Sorry, I'll scroll up to the problem. My bad. So the thing is that we have to do it in place, right? We have to do it in place The order of the elements may be changed. 2, 2, 0, 1, 4, 0, 3, 0, 1, 4. So how did they get this 3 to become up front? That might be telling here. So they started in pop. Huh. You read a hint. Problem statement clearly asks to modify the array in place and also says that the element beyond the new length of the array can be anything. Given an element, we need to remove all the occurrences of it from the array. We technically don't need to remove that element per se, right? Yeah, you don't need to. So then we can remove all occurrences element, move all to the end of the array with 2 pointers. Yeah, exactly. The last element in the array. Got you. So we were on the right track then. So we'll say for I in the range of n, and then for j in the range or say while j is equal to negative, or is n minus 1, they say while j does not equal to I. We'll say while I does not equal to j to make it more consistent. Okay, we want to say we have 2 pointers, one at the end. So if nums index I is equal to val, right? We'll say if if nums index j first off is equal to the val, then we want to reduce j down by 1, right? If nums in, so then that'll reduce j down by 1 and then move to this call here. And then continue the loop again. If nums index I is equal to the value, right? This means this wasn't met, so nums index j is not. We want to swap nums index I. So temp equals nums index I. Nums index I becomes nums index j. Nums index j becomes temp. Right? So if nums index j is equal to the value, we'll reduce j by 1 to bring it down in from the back of our array, and then continue the loop again, because we have to first have our last value not, because we don't want to be swapping values where our right side, our right pointer is that value. We don't want to swap that to the front. We only want to swap it if it is. But we don't want to move our I unless we are on a j that is not the value. So we are currently moving from the back the j if it is the value equal to, right? And then we'll continue the loop, okay? So that'll continue again. And so in this case, like this example, that's where it will happen on that first iteration. It's going to have a left pointer here and a right pointer here, right? If j is the right pointer, which is the right pointer, is the value, which is 3, we're going to move it in, but keep our I where it is, right? So that'll keep I where it's at, right? That'll keep I where it's at. reduce I by 1. But then in this one, we'll continue to reduce I down until... So I don't know if this will be the best approach either, but this essentially will do it. So let me copy this over into our Python. You don't have to swap, you can just assign. Okay, that's a good point. So if we don't even need to swap, we can just assign the underscore like William is saying. So if num index I is equal to the value, we don't even need to save a temp. We don't even need to resave the value. We can save num index I is equal to this, and num's index j is equal to an underscore, right? Like so. So I think that that'll work. No? Is there, we might be missing something, but that's the gist of it, I think. Let's put in numbers from the example here. Numbers and a value. Like so. Oh. Okay, so then what are we returning? We're returning the array, but we need to have a counter as well, right? So we have swaps equals to 0, swaps plus 1, right? So then we're going to print here nums and swaps. So the output is swaps and then numbers, right? Oops. Swaps, then swaps, and then nums equals nums. Like so. Okay, so then that's being said, let's see what happens here. Unequal J, keyboard interrupt. Oh, hold on, we have an infinite loop going on. Hey Rex, how's it going? Welcome in. How's it going? So we need to swaps plus 1, and then we need to break, move on to the next value of I. And we still have a loop going on that we're stuck in. Oh, because we're not moving ij down again. So j goes down. So we're going to break here. Break. So we break right away, do minus equal 1, and then move back. But that sets j, and okay, so that's why. Oh. Um, so that's a good point, Vance. You're doing the two-pointer method, so I don't know if you need a for loop unless that's kind of the specific part of the problem. You can just use the while loop alone. Yeah, I think that's why we're running into this issue here. So if we use just the while loop, while I does not equal to j, so I is equal to 0, j is equal to n minus 1, right? We do j minus equals 1 and then continue. And then we would want to do swaps we need to bring in I and bring in j. So j minus equal 1, I plus equal 1, and then continue the loop from there. So that will bring j down. We want to bring j down if it's currently on the value before anything else, right? Right? Then we want to do another conditional check, a required if check, saying if the number at index I is equal to, meaning that by inference that the number at index j is not the current value that we're looking for, but the I is, we're going to swap them and save the number j as the underscore. We're going to increase our swaps here, and we're going to reduce j down, so j moves inward off of the underscore, and I goes up to the next value. Okay, so now if we run this, okay, now we're closer, but not quite there. Right, so we're getting now 1 for swaps, and we're not doing that last swap of the 3 initially. So I is equal to 0 and minus 1. So if the value, which is 3, we're really close here. We're almost there. So if the value that we're currently on is so we're not swapping this last value. We're missing it for some reason. So if it's equal to the value, go down. No, so if it's equal to the value, we're going to set the value here. Nums index j is going to be set equal to the underscore right here. So now if we clear this out, we need to increase swaps here as well. No matter what, swaps gets increased on every loop. Oh, no, only on these cases. There we go. That's the answer I'm looking for. Okay, now if I give it this one, let's see what happens here with a value of 2. Let's give it this guy and a value of 2 this time. So we're looking for output of 5 numbers with 3 underscores at the end. Now we're getting an infinite loop again. Shoot. Why were we getting an infinite loop on this one and not the one before? Clear. Oh, because in the first case, you're doing nothing. So else, right, we need an else statement that says else we need to move j down 1 and I up 1 and continue. So that'll still give us that. Perfect. And now if I give this guy here, because we needed that else statement there, and give a value of 2, index error out of range. Oh, shoot. Now my I becomes out of range. Let's increase I. No, we don't want to decrease j. We want to leave it. We just want to increase I. There we go. But that's 3, shoot, for the total number there. But we want the, okay, so we don't want to count the number of swaps. We want to count the number of remaining values. So we need to return swaps and minus swaps, rather. Perfect. I think that's our answer. Woohoo! We'll find out. I think that's our answer. Okay, let's go over and put this in here. What do you guys think? Okay, here we go. All right. Let's go try this out. I'm nervous. I'm nervous. What do you guys think? Okay, we have I is equal to 0. J is equal to n minus 1. Right? We're going to say while I does not equal to j, we're going to say if numbers index I, or numbers index j, so we're checking the right pointer, the last value in our list currently. If that value is equal to the value we're looking for, then we're going to replace it with immediately the underscore, right? And swaps increases by 1. We decrease j down because we already evaluated that value, and we continue the loop back over, right? We're going to if that condition is not satisfied, right? So I guess this could be an elif, because if this condition is satisfied, the elif, that if won't even be evaluated. So because of the continue here. So elif Richard, are you alluding to something? Do I have something wrong? Richard might be he might be saying, Mike, we're not all the way there yet. So if the numbers equals the value at index I here, by inference that it doesn't equal at index j, we're going to set the value numbers index I equal to numbers index j, moving that number down into that place at I, and then saving the numbers at index j as the underscore, basically mimicking that swap, but just for an underscore. So I don't have to use a temporary variable. We're going to increase swaps by 1, decrease j by 1, increase I by 1, and continue. Else, we're going to increase I by 1, increase 1, and continue. Right? And so at the end of this loop, we're going to return n minus swaps and nums. All right, That's my code so far. Let's go and see what we got here. Let's try to run it. Ah! Oh, shoot. Cannot access a blur swatch is not associated with the value. Oh, I don't have it in here. Sorry. Swaps equals 0. So if we run this. So it's just, it doesn't like my return value. So how does it want it? Um, how does it want it to return? Return K? Oh, okay. Just return K. Aha, we passed the woohoo! That is so satisfying. We did that one. Oh, yes. Woo! Okay, now if we submit, we might, or we're probably gonna fail here, you guys are saying. Um, I know it looked like you nailed it while we're doing this more complicated problem. I was merging arrays. Oh, gotcha. Okay, so let's submit. Ah! No! Oh, okay. What did we get wrong? Oh, on a blank array. Ah, screw you. Come on. A blank array. Get out of here. Um, dang it. Numbers one. Oh, shoot. Okay, so we have to. We can't cheat it like that. We have to say. Because it wants k, so swaps is 0. So if n is 0, return swaps. N is 1. Output is. Expected output is blank. So k is the length, return numbers. So we'll just do like this. Actually, we'll say k equals swaps. We'll just go like, we'll just compute k, how about? K is equal to swap to n minus swaps. Return, instead of this, we'll return k here. So if n equals 0, return swaps, right? I think that'll work. No. Ah, come on. I'm not even. Oh. Oh, doesn't. That's why. All right, here we go. Try it again. Here we go. Come on. No. Shoot. It wants a blank array. Expected blank array. If it gave me a numbers of 1 and a value of 1. Oh, okay, so I'm not removing it. There may be a hint of the edge case in the if I look close enough. Oh, don't look at that. Um, Given integer, move all the currents of val and nums in place. See what they must be. Consider the number of elements which are not. Change the arrays like here. Change the array numbers of the k first elements contained. If n equals, okay, so I need to do an evaluation at the end there and say at the end of the array, if swaps, okay, so you have to say if swaps is equal to n, if swaps is equal to n, meaning that 0 swaps, 0 values, 1 swap, it'd be n minus 1. If swaps is equal to n minus 1, we want to return numbers is equal to an empty array. Return k. Right, yeah, exactly, Richard. That's what I'm trying to, I think we're on the same page here. So if swaps is equal to 1, but we want swaps can equal 1, but we have to also reference the length of the array, meaning that if the length of the array with 1 swap is 1, so if swap is 0, length of the array. No, you're all good, Richard. I appreciate you. Oh, shoot. So if n equals to 0, meaning that there is no values, you're going to return 0. Okay, perfect. At the end of the loop, if you ended up having swaps equal to the amount of, so let's say you have 1 value in there and you made 1 swap. So n is 1. So swaps is equal to n then return the blank list. And then set nums equal to the blank list. Right, because if swaps is equal, so let's say you have 1 swap and your end is 1, you swap the only element in there with the underscore, you override it with this and return. I think that'll do it. So let me take this then. Let me go back into my Python here and say, let me take this here, put it over here, bring this in. I'll bring this over for you guys so you guys can see. So what I'll do is I'll tab this out, I'll go def, delete, given nums some value. Print delete on nums and value. Okay, that gives me 5. So that still works with that. So then return k nums like that. We'll see what that's okay. Okay, perfect. So that still works for that. So now if I give it a case of 1 with a value of 1, we should be getting one swap with a blank array. No, one swap with a single array here. So if swaps, so if n is equal to 1, so then I guess you say elif n is equal to 1 and n nums index 0 equal to value, nums is equal to this. But that kind of just check the function left to go. Oh, gotcha. You're almost there, dude. You got it. You got it, Ryan. Okay, so but then return so k does equal 1, which is n 1 minus swaps 0. So I think that'll work, but I'm not sure if that's like the best way to solve this edge case. This is kind of cherry picking. So if we say return swaps elif n is equal to 1 and nums index 0 is equal to the val, set nums equal to a blank list. So run that. We still pass. Can I add a test case? Yeah, I can. Cool. Let's add that test case that it wants of 1 and a value of 1. Okay, cool. That's really nice. Didn't know you could do that. So now if I run, output 1. Why is that not overriding? So swaps equals 0. If n equals to 0, return swaps. elif n equals 1 and nums 0. Okay, Richard, I like your approach. You're saying there's a way to do it within the loop to not cherry pick. So if numbers and hey Jason J, welcome in. I'm sorry, I think that is it Japanese or I'm not sure what it is. Thanks for coming in. It says I don't even want to touch leak code because I know it'll take hours for me to solve. Yeah, I often feel like that too. I sometimes am reluctant to even jump into it just because I know the amount of brain power it requires of me to solve these problems. So, but also at the end of the day, you're getting better. So, Jason says instead of using Yeah, exactly. So we are using one loop. We're only using one while loop. Yeah, we're only doing one loop here. So k equals n minus swaps. If swaps is equal to n. So we'll move this. So it's wanting a blank array, but what if I move the item off? Okay, so if n is equal to 0, we return 0. So that takes care of that case. If n is equal to 1, so can I go like this? If n is equal to 1 and numbers equals or equal to the value, we're going to nums.pop and break. And swaps goes up because you made a swap. N is 0, swaps is 1. Oh, but n will be 0. So n is swaps. The value should be 0. So swaps is 1, n is 1. So we don't want to pop the value then. One minus one is 0. Or 0 value in there. But why does it want a blank array, not a underscore array? Like that. Expected. I outputted a 1. So if n is equal to 1, oh, because it's not even entering this because 1, okay, I got you. So that's why we can't even do this in the loop, because it's not even entering the loop because they are equal to each other, I and j. So we need to take this, move it outside, elif n equals 1 and nums equals 0, swaps plus 1, break. So we return. This won't even enter this. Okay, how about that? There we go. Now if we submit, dang it. Ah, shoot. Okay, so now we're getting another wrong test case of 3, 3 with a value of 3. So we should be getting so we're outputting 3. So if they're both the same, if they're both the value, what do we want to do? If the right pointer and the left pointer are both the value, we just passed over right here. We need to uh, shoot. It's just these little. So let's see here. Let's go to these other hints here. And 3. Yeah, another direction of this is consider the elements to be removed as non-existent. In a single pass, if we keep copying the invisible elements in place, another direction of thought is to consider the elements to be removed as non-existent. In a single pass, if we keep copying the visible elements in place, while it doesn't equal to the target, if it does, okay. So we're not. So if it's equal to nums, let's say the answer to this problem once used to return the count of elements. T already counts the elements, right? Yeah, we have that. Well, swaps equals 0. We're increasing swaps on every time we do this. And then we're going to return n minus the swaps. Hey, Santiago, how's it going? Welcome in. While index I does not equal j. So what happens though if both of our pointers are on the values? We need to okay, so if both of our pointers are on the values, so if numbers index I equals to the target, to the value, and numbers index j equals to the value, we want to set numbers index j equal to a underscore swaps plus equal 1, and then we want to move j down 1 because we want to find a place where I we want to move j down 1 and leave I where it is and continue. So if this is one of the cases if they both equal it. Now if on our final pass, if nums index I equals to val index I will equal to an underscore. So we have to override at the end, no matter what, for do that last check, right, on the break. So swaps plus equal 1. If, elif, else. And then we need to bring this outside of the while loop. So if I run that, that will pass that case now. Perfect. Now if I run this, oh, submit. Ah, no. Value for line 15, remove element. Doesn't like this. If numbers index I is valid. So bring in the left. Continue with that one. Okay, now they're not equal. Swap it. Bring them both in. So this is 4, 5, value of 4. So we need the else statement still. Okay, so let's think about this. Obviously, we're so if n is equal to 0, we return 0 right off the bat. Okay. If we have 1 in that case, then we'll do that. Right. So while I is equal to j, if they're both equal to the number, we set j to the underscore, increase the swaps, and move j down to their left. Continue again, meaning that our I will remain on the value. Next, if numbers index j is equal to the value, and nums index I does not equal to the value, right, we're going to increase continue. So then we can say here like this, we'll put an or here, put this condition inside there, like so. And then we can just remove this if completely. So if the numbers index j equals to value and the numbers index I does not equal to the value, or numbers index I equals to value and numbers index j equals to the value, we're going to set the numbers index j to the underscore, increase the swaps, and decrease j down, right? So in both cases, numbers index j equals to the value. So if numbers index I doesn't equal, and move, no, we need to move I in though. So if it doesn't equal to the value, we set this one, increase j, and then also need to increase I, right? And then we can remove this completely. Now what happens if the numbers index so this is if the I, so if I doesn't equal the value and numbers index j does equal the value, we're going to, okay, so I'm sorry, okay, I'm sorry, got you. So if numbers index I equals the value and the numbers index j equals the value, we're going to set the j to negative to underscore, increase swaps, and move j in. We need to leave the I where it is though, because we have to perform a swap when j finally does not equal it. So elif, when numbers index I equals to the value and numbers index j does not equal to the value, what do we want to do? So if numbers index I, the left pointer, equals to the value in target, and numbers index j does not, well, we don't want to replace the numbers index j with it, with the underscore. If it doesn't on the right and it does on the left, we need to swap the values. So numbers index j becomes numbers index I. No, numbers index I becomes numbers index j. We swap the j value over and then make nums index j equal to an underscore and then increase swaps, right, by 1. So equal, not equal, equal, not equal. This will be the else statement then, that they're equal, 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 not equal, equal, not equal. Hold on. No, so this is elif still. Then the else is if they're both not equal to the value we're looking for. This guy's only checking the first k elements, the size of the array with the elements removed slightly. Unfortunately, Augusta, the question specifically asked to do this in place, so we have to swap elements in place on our to have a linear iteration. So yes, it would be perfect if we could just, remove the element and then provide the length of how many elements were not that element, right? But unfortunately, it is actually checking the nums array in place. So we have to do swapping. So if they're both equal to the value, so if we have 3 and 3, we're going to set j to it, the underscore, move it down. Okay, that'll break, and then this will hit and cause that to go forward. So boom, that takes care of that. So then, right, if the left pointer is equal to the value and the right pointer is not, we need to swap the right pointer to the left pointer and set the right pointer then to the underscore, which is what we do. If the left pointer is not equal to the value and the right pointer is, we just need to set the right pointer to the underscore and move both inward. So I think that will take care of it. Okay, so now we have this guy here. So my 4 test case passed. Now this guy's not passing. So my value is 2. Expected is... Uh-oh. So value is 2. Yeah, sure, Jason. No worries. You can DM me. Um, we're close, but not quite there. So on the value of 2, why are we getting rid of the 0 as an underscore? Why is the 0 being underscored? Let's swap it. That one. If they're both not the value, we leave the right pointer where it is. Okay, so if they're both not the value, so they are left one. So if they're both not the value, we want to just increase the left pointer and leave the right pointer where it is. Yeah. You can initialize a tracker. You iterate through the array and find elements that are not equal to the value and simply you initialize a tracker. You iterate through the array to find elements that are not equal to the value and simply say numbers index tracker, no, array index tracker equals nums index I. But you're creating another array, right? You say it there. Simply say array index tracker equals to nums index I. So you are creating another array in memory, which is what we're not supposed to do. In place. Operates on the input data without requiring any extra space or to the input sites. Otherwise, it modifies the input in place without creating a separate copy of the data structure. an algorithm which is not in place is called a not in place or out of place. Okay, so let's go like this. Let's take what we got so far here. We're really close, I feel like. Let's go here. Say I am working on the LEET code problem 27, remove element, and am getting nums tracker. Okay, so you're saying nums tracker. So you keep track of a swaps, basically, which is your tracker. You iterate through the array. So let's go like this. Let's take all this stuff. Let's comment it out. Let's move it down. So for I in range of n, if nums index I is equal to the value I'm not sure I remove. So Richard, you don't have to remove the values that are zeros. You just have to replace them with underscores per the problem. Like, I mean, you could essentially pop off the amount of swaps but right, because they're at the end, so you could just do X amount of pop operations per the amount of swaps. So in your case, it would be 2 swaps for both zeros. So you would do 2 pops at the very end of the loop. But if you just replace them with underscores, it kind of making that swap happen, then yeah. Let me see here. Okay, so you iterate through the array to find the elements that are not equal to the value. So if the current value one is not equal to the value that we're looking for, then we say that the nums index swaps is equal to nums index I. So if we're not equal to it, so in the first example, we have this. So our value is 3. So we're first on this one. So if we are on the value, okay, nothing happens. Move on. If we're not, so we'd go to numbers index swaps, which is 0. Numbers index swaps, which is currently 0, is equal to numbers index I. Yeah, right? So this will say, and then we need to increase swaps by 1. And then at the end of the loop, go for okay, so you just take the value currently on. If the value is not the value, we're going to say, okay, swaps 0 should be the previous one. And swap num I. So then you just need to pop off the number of swaps, basically, at the end. So swaps for range swaps nums dot pop, and then return k is equal to n minus swaps, return K. All right, let's try that. No. Invalid syntax for I in the range of n on line 8. Oh. Why am I forgetting the in all of a sudden? Okay, so now we just need to handle some of these edge cases, I think. So in this one, output was 3, 2, and expected was 2, 2. So for I in the range of n, if the current number we're on is not equal to the value, we're going to, so in the first example, it's 3, 2, 2, 3. We go for I in the range, so 0. If this is equal to the value, okay, it is. So we're gonna, if it is equal to the value, we move on to the next one. Okay, so now we move on. Okay, this is equal to the value. Oh no, so this is equal to the value, right? Sorry. So we go ahead. Okay, so if it is equal to the value, what do we need to do? I mean, we can pop the value, but that'll mess up our next iteration. So that's why so if it is equal to the value, how do you get it out of there? You need to swap it. Right? If it is equal to the value, okay, so if it is equal to the value, now we need to do the 2-second pointer and evaluate the end? That's what I'm doing right now, though. If it's equal to the value, I am doing nothing, and I'm not getting the correct answer because it's passing over that 3, right? Right? It's passing over the 3. So it's going right here. It's saying, okay, it is equal to the value, so it's doing nothing. Then it goes here and says, okay, it's not equal to the value. So we need to push this. So if it is equal to, so it's not equal to the value, it swaps it out with index 0. So num's index 0 is equal to that value too. So why am I getting 3 here? Right, because if it is equal to the value, it's passing over it, so it's passing over the 3. It comes up on the 2 and says, okay, this is not equal to the value. So we need to swap it with the swaps counter. So in this first example, let's just break this down. In this first example of 3, 2, 2, 3 with a value of 3, right? I am on the 3 in my first loop, right? It does not it is equal to the value, so it moves on in the loop, right? It moves on. So now we're on the 2. It does not equal the value, so we save the value of n index 0, which will be this 3, which is the value, to whatever the current value we're on. So the 3 now becomes the 2, and then we move on. Now we're here, okay? Okay, this is not the value, so swaps is now 1, so we take 2, goes 2, okay, there. The loop moves on, but the swap variable is still on 3, so when it finds the 2, it's equal to 3. Yeah, I know that, right? Yeah, that's what I was saying. But in my output here, we are still remaining with the 3 out front. So it's doing the final swap then, is what it's doing. So if it doesn't equal the value 2, so if we're getting, so we're starting the 3, it does equal the value, so it moves on, but our swap stays at 0. We move on to the 2, okay? We perform the swap, so the 2 comes here and the 2 stays. Now we have 2, 2, 2, 3. 2, 2, 2, 3. 2, 2, 2, 3. Now we're on here. Now we're on here. Okay, this does not equal the value, so we swap here, so that stays 2, 2, 2, 3. Now we're here. This does move everything after the first for loop. Remove everything after the first for loop and just return swaps. Because the swaps is tracking how many don't equal the value, so that is why we don't need to do that inversion of k. So those edge cases work. Now we're dealing with this here. Expected output. So it's still getting my values. And still the 3 out front. Where is that 3 coming from? Which one is it? Is it the first 3? No. It's got to be this last 3. Swaps index Nums index swaps. So this will be 0, 1. I'm going to see what happened here. 3, 2, 2. So what happens if I swap these two variables? And I'm not sure. I thought... No, it comes out. Oh, swaps. Oh, it's still expected 2, 2. So that wasn't it. Oh, so I just need to set equal num swaps. If numbers index I does not equal to the value, set, we're not doing a comparison, we're setting it equal to the swap. So now we run. Okay, so we weren't actually doing the appropriate swap, which is what was happening. So then why, my question is I know I had this bug here, which is doing a comparison rather than actually doing the setting of the variable. But what was being passed over in this bad run here? If swap, so it's going not equal to it. Okay, so it's not. Then it checks this. This is just a true or false statement. This gives back a false. And then increase swaps. So in this version here, I'm just trying to figure out what was going wrong with, I know that obviously the operator was wrong, but where was the loop actually performing? So 3, 2, what happened to these other two values out front? Is why did those disappear? Output 3, 2. Oh, because it's only trying to read. I think that the problem here, this judge is only trying to read the K values, the slice of K pretty much, right? So it's only reading these two values, and when I'm doing this, my array is never changing because I'm not actually setting the value just like that. So now it's going to read the first up to K values and see that it is 2, 2, not 3, 2. Okay, so that's, I wanted to understand why exactly that setting was incorrect. So I know that operator was wrong. I just had a typo. I had an extra equal sign here. But what was going wrong with the actual under the hood was that the judge is evaluating the first K elements, the swaps returned. So, right, it's taking basically a slice of my list and evaluating the first K elements. It's not, evaluating the, and so what it was doing was, it was going through and saying, oh, your list actually never changed because when I was kind of getting to that debugging, right? I had this double equal sign. I put right here, I put print nums, and I did that, right? And then it showed me, I was getting there. It showed me that my list never changed, right? That was my tell right there. My print statement on each loop, my list is actually never changing. So what if I just remove that, run, this will show that list is now being changed just like that. Perfect. And so now, so then what's the whole point of the this hint here for wanting to Woo! What's the whole point of this hint here for using two pointers approach? We can move all occurrence of the element at the end of the array using two pointers. I mean, is that just like the more streamlined, like that the logarithmic pattern or the algorithm pattern approach is to use two pointers, but there is this kind of single pointer approach? I mean, you do have a second pointer, I guess, right? That just lags behind where the most recent swap was, right? So you do have two pointers, but you're not doing it the typical way using a nested loop or something like that, or like a value greater than the your index I. You're having a second pointer lag basically to identify at what previous position did we perform a swap, or did we see, sorry, at what previous indice did we see a a value equal to that value. Oh, that was a fun one. Thank you so much, Jason J and Agastia. Thank you guys so much. You guys are awesome. Thanks for helping me out with that one and your patience. I really, really appreciate your patience. I've only been learning this for about 6 months now. And so, these leak code problems, they can, my biggest struggle, honestly, is I think that they're maybe more grand or there's more to the problem than there might seem. And so I try to maybe upplay it or upsell it or somehow to making it more complicated. And then I oftentimes end up down these rabbit holes where then I have this sunk cost, or I'm like, oh, I've already been down this hole for 45 minutes. I'm not going to quit now because I've all this time invested into this one approach, when in reality, it's better for me to try to go back and start from a scratch, right? Hey, Chance Burr. Hey, I'm new to code. I'm like new. I'm working on learning Python as well. I was wondering what options were on the self-taught options. Yeah, hey, how's it going, Chance? Welcome. I appreciate you joining me here. I've been teaching myself Python for about almost 6, 7 months now. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company where I make biological controls for patient diagnostics and clinical research, or pretty much for anyone who wants to buy them, I guess. I make large liters batches of solution, upwards of 2,000 to 4,000 liters that get bottled down into small vials and sold off that way. I I've been teaching myself programming though because I want to further my education, and being a physical scientist, I find that programming and data science is just so fascinating that we're able to improve our calculations and computations via in chemistry or whatever science with computers. And the fact that we've been able to create computers out of just raw physical elements is also fascinating to me. I really appreciate you guys all being here and joining with me. I stream every single day around 7 p.m. PST. I come on a little bit earlier on the weekends just to help with getting access to those East Coast viewers and to the international friends on here that I stream into the late AMs for them. But anyways, yeah, we just solved this remove element problem. So my original first approach was I had like 20 lines of code here, right? This was my original first approach. Was I was doing this two pointer, like the hint suggested, to actually swap elements when I came across them, if meeting those certain conditions. But per some suggestions here, is you don't even need to do that. You can just use a single kind of pointer, but have a lagging pointer that you know um, will keep track of the indice of a seen value that is equal to this value, right? So this swap does not change until we actually find a value that doesn't equal to the value provided. And so that essentially just creates a lagging indicator saying that at this index of swaps, right, this value, if you translate it to an index, we have a value that needs to be swapped out for something else. So, and then once you get to a value that isn't, do that swap. You can get it out of there basically. So yeah, this one was an interesting approach. I hadn't seen it happen this way. I've always been doing that for I and then for J, which is just a little bit higher than I, or one pointer, or maybe at the back, right? This is one of the more fun, quite easy questions. 6 months is good. Keep going, brother. Awesome, Jason. Thank you so much. I guess don't worry. Virtually every lead coder has that issue, even proficient ones. There is a function self dot remove element nums val. Yeah, probably pulls right from this. They probably won't let you use built-in methods for this interview question. Yeah, let me just write a one-liner self dot remove nums val, and there you go. Done. I wish it was that easy. They might applaud you on your knowledge of Python, but they might want you to break it down a little further. That was fun. I mean, it was definitely a challenge, right? I did work on that for a good, hour or so, grinding through it. And but that whole point that you guys saw me struggling through it, and yeah, I might kind of look foolish or I might not look know what I'm doing, but that's a whole process of learning. And I think that's what deters a lot of new people from attempting these problems is that they might look foolish or they might look dumb. And yeah, I kind of do have that feeling a little bit inside of me. About 10% of me feels like, man, I feel a little bit, dumb that I didn't know that. But how can I feel that way when I didn't know the solution to begin with? So through that process, that is what is learning. That's what's called learning. And so uh, we'll just be, we're setting ourselves up better for next time. We got good practice using indexes. The fact that I was able to kind of somewhat understand this logic, I think is a pretty good improvement. We were able to solve the problem except for some of these minor edge cases. So my logic and understanding using these pretty, annoying and complex indexes and Boolean statements and concatenations really, it does show that I'm kind of getting better, but obviously there was a more simple approach here. But I do applaud myself. I was able to get using that kind of crazy logic, kind of force my way to an answer almost. Good to know. Was this a two-pointer solution? Yeah, so this one does talk about using two pointers, but it's not like that. Like I was saying, it wasn't like the two pointers in the normal way that I've been normally doing, where I say like for I in the range of n, and then for j in the range of I plus one or one to n or something like that. So it just leads. In this case, the second pointer was a lagging pointer, right? Now, I was kind of working towards a solution in that the other attempt that I made where I was using a right and left pointer, one at the back, one at the front, and then moving them forward strategically, based on some logic. But this obviously is way more simple. But on LeetCode Hearts, I think they allow maybe some. Okay. Yeah, we haven't ever tried a hard one yet. We're definitely not even close for that. We're still barely even able to solve some of the medium ones. Even we're still barely even able to solve some of the easy ones. So, it's all in fun though. Cool. That was that one. All right. Let's go ahead and should we do some live coding here on the project? Let's go open up the small business manager. All right. So this is the small business manager that we're working on. We've been writing this project for the past, about 2 months or so. Um, it's pretty elaborate here. It's not nothing too crazy in terms of like the actual functionality, but it's just starting to get pretty dense in terms of the amount of material we got going on here. So, if you guys also have any questions about how maybe I got started with my projects, I know that I've gotten a lot of requests to maybe go over how I actually get started with projects or my thinking regarding that. So if you guys want me to go over that, just let me know. No problem at all. But yesterday we wrote this function here, right? Which will initialize a dictionary within a dictionary of various statistics relating to the expense information, right? Um, so I'm gonna say info here rather than categorized info expenses. I'll say info here, right? So what this function does is in our business JSON here is now we actually have our annual gross expenses broken down into different, sub, even further categorizing these down. So the expenses, right, they have a category and a method associated with them. And so what we're doing is we're breaking down each of those segments into annual reports. So what I can do here to show you guys what's going on is we'll go into the program, we'll run it. Let's go into inventory. Let's add an item. We'll say this is a dress. Well, it costs $10, medium, and we'll use today's date and say we have one of them. Let's add in another item. Let's say this is a shirt. Well, cost was $15. Size is a large, today's date, and one of them, right? So if we go over to our items.json, as you can see, both of those items are in there appropriately. Let's go ahead and go back to the main menu. Let's go to transactions. Let's go item search, item number 1, right? Let's go transact item is sold. Let's use today's date, and let's say we sold it for $20. And then we have a standard shipping method and a shipping price of $5. Boom. So that updated that. Now let's go ahead and item search again. Number 2, let's transact this one as sold. Let's say yes. Sold price is $30. Let's say this one was delivery. So boom, just like that. So now what happens, right, is based upon those sales, right? We made some sales via those transactions we made, totaling a total of $20 and $30 for a total price of $50. So that is our total gross revenue, right? Of just income without expenses taken out. That's gross revenue. Now this says 20,000 and 3,000 because this is converted into whole cents, US cents, but this is $20 or $30. Now, right, now obviously as well, we have a couple of expenses that were generated. One for the item number 1. One for item number 2, and then another expense number 3 that was a note called ship cost for item number 1, right? So that's kind of fun, interesting. Item number. So item number 1, if I go to item number 1, this was standard shipping. Oh, because I converted, okay, so that's why it's not in that order. It's not in the same order because I did both of these at the same time and then I converted them afterwards. So that's why. So that's why it's not the expense 2, this is an expense 2. Okay, so I can make these both at the same time and then I still made a sale. So right, this generates the sale appropriate with showing that this is the ship cost for item number 1 in the note. And then see what we can do now is now that we have sales and we have expenses that are categorized with shipping categories or methods or whatnot, is I'm not giving these any method by default. So if I were to need to go, I have to go to main menu. So we need to fix that formatting. Let's go expenses, add expense, yes. Amount was, let's say it was $25. Gas, shipping, method was credit card. No note. Right? So now we have that expense created that has a method associated with it. So now what happens is if I go ahead and relaunch the program, so as you can see here, guys, that $50 is being calculated and included here is we have $20 for a charge, $20 for a charge on item number one, and $30 for a charge on item number two. So we have a total charge of $50 for gross revenue. But we have $55 of gross expenses, or sorry, of yeah, $55 of expenses because in our expenses.json we have 10, 15, so 25, 30, plus 25, 55. So that's where that number is coming from. So then what happens if I go ahead and go main menu, exit, yes, and I relaunch the program? These will now be generated and filled in, right? I have these hard coded in there, but they'll be filled in because in my business pie now I have some methods included. Credit card, right? So now they'll be included and populated for their individual categories and methods. Boom. So that worked right there. So we have inventory 2025, shipping 2025. So that breaks it down by year. Perfect. So now almost 1:30 here. Unlucky Jimmy Grant. All right, I need to go get some rest. It's almost 1:30 here in Canada. I'll see you guys tomorrow. See you, Unlucky Jimmy Grant. We'll be studying again tomorrow together. I look forward to seeing you then. See you, man. Later. Have a good one. Good night. So then this isn't being updated though, right? So we have because this is going self. But this business itself has credit cards on its methods, expense methods. So it's not creating. Okay. We'll have to figure that out because if they add in a method here, that's interesting. All right, you guys, I'm going to go ahead and call it here for tonight. We streamed for 3 hours and 13 minutes. Thank you guys so much for joining me here. It was a really, really fun one. We did, let me see really quickly if the CS50 is working. It wasn't working earlier. Ooh, come on. Come on. Remember, we were having problems with it earlier. It wasn't working. Still loading here, little by little. Connecting to code space. Woo! Okay, now we're back. All right, sweet. Okay, we're back. Nice. That is awesome. Okay, so now that this is working again, tomorrow, you guys, we will be completing the problem set 7, week 7 on SQL. So be back in the stream tomorrow. We'll probably jump in maybe around noon is my goal. We'll come in for a beginning, a part 1 stream, a morning stream where we'll complete week 7 of Harvard CS50X 2025, where we're doing all about SQL and integrating it with Python. And then we'll take a break after that stream tomorrow and then come back for a part 2 in the evening around 7 p.m. like our normal time and do DSA and Python, leak code, and practice problems on the project. All right, you guys. Thanks so much for joining me here. You guys were awesome. Super, super interactive chat today. I really, really appreciate you guys supporting me. Make sure to thumbs up and subscribe to the channel if you're interested in hanging out with me every day. I stream every single day. And we'll be back tomorrow to complete that Harvard CS50 problem set. So be back here tomorrow if you want to participate and be involved in collaborating alongside the problem sets. It's a great opportunity to do it in pairs or do it in a group if you struggle with working independently, especially when completing those problem sets and maybe finding out ways to start. It's a great opportunity to work together and come up with those solutions and just bang out the course. Like if I'm going to do it the weekend, I'm going to be solving the problems. You might as well jump on with me and solve it too and complete the week as well. If you're going to be watching it, you might as well complete it too. So we'll do that tomorrow, and we'll go into further. I honestly, my project work, I after it's hard because we do the project at the very end, and so oftentimes I'm kind of like out of energy by the time it gets to work on the project, um, which is kind of annoying. So I'm sorry that we kind of do a little review of the project and then kind of say, we'll tackle it next time. But after we're doing 3 hours of learning, it gets pretty difficult to keep the brain power going to work on the project. But anyways, I really appreciate you guys joining me here. I'm trying my best just to learn this at my own pace, without any pressure, and just kind of creating a community alongside myself. I'm really trying to convey a beginner point of view that's authentic. I found that a lot of people on YouTube with fancy editing and with the not being able not live streaming it, they can kind of convey a beginner point of view, a perspective that is pretty unrealistic, and often kind of times can maybe discourage beginners from wanting to try, as they might be comparing themselves to levels of programming that they honestly is pretty unattainable for some beginners. So I'm really trying my best to portray like what it is actually like to really grind through this stuff 100% on your own, trying to learn it and reflect that guy towards you guys for some comfort or just as a document, a series. So thank you guys so much for being here and dealing with my rambles and my yaps and helping me with the elite code problem for tonight. Super fun. I'll see you guys back here tomorrow. Message me in the Discord if you have any questions and want to chat and get access to my resources. I'll be in there and can message you this evening. So see you guys tomorrow. Bye.